11.4, Introduction to Derivatives. So we're going to worry about something today called the slope of a tangent line. So the slope of a tangent line represents the rate of change in the curve at that instant. So another name for it is going to be instantaneous rate of change. So it's the slope, but it's also my instantaneous rate of change. So the rate of change, what's going on at that point at an instant. So the issue is that if I want to do the slope of a point, I don't have enough information. My slope formula is y2 minus y1 over x2 minus x1. And if I'm just at a point, I don't have a y2 and a y1. So what we do is we use this idea of limits. So I have 2 points here on my curve. One of them is x comma f of x, and the other one, instead of my x, now I've taken and added h there. So instead of just x, it's x plus h. And then instead of my f of x, so f of x would be like my y value, I have f of x plus h. So I'm going to look at finding my slope formula between these two. So that means we do the f of x plus h minus the f of x, that's up here in my fraction. And then in my denominator, I would do x minus x, so x plus h minus x, that's this denominator here. And then when we go through and simplify it, we get f of x plus h minus f of x all over h. So that is really my slope between those 2 points. But we have this idea of limits now. So what I can do is I can get these points closer and closer together. I'm trying to just grab the point and not the graph, but it's not going well. Here we go. If I get these points closer and closer together, that means I'm basically making that h go to 0. Okay, and that's what I want to do. I want to make the limit of this right here. I want the limit of that as h goes to 0 so that the distance between those points becomes just nothing. That's what we're really looking for. So in order to find the slope at a point, I use that expression, f of x plus h minus f of x all over h, and I find the limit as h goes to 0. And in that case, my x and my other point would just basically be the same thing. So this should look familiar. We've been doing this formula for a while. So the difference is that you've been practicing it all this time, and now we're going to actually look at what it does in math. So for number 1, I want to find the slope of the tangent line. And I have a graph, f of x equals x squared plus x, and then I have a point. So the first thing that I really want to do is I want to do that thing we just wrote out. Limit as h goes to 0 of f of x plus h minus f of x all over h. So that's how I'm going to find an equation for my slope. M is going to equal that. And then once I find my equation for my slope, then I'm going to worry about the point. This is going to have a couple steps to it. So to do f of x plus h, that means I take this function up here, and everywhere I have an x, I put x plus h in. So limit as h goes to 0 of, so for f of x, I would now have x plus h squared plus x plus h. So I've taken, again, this formula, and both of these x's, I now put an x plus h in. So that's that first part. That's this f of x plus h part. So let me put brackets around that so you can really see it clearly. And then I have a minus sign, and then it says f of x. Well, my f of x is that x squared plus x. And I'm going to put brackets around that too, just to really clearly see what's going on. So I took my function and I plugged in x plus h, and then I just took my function and wrote it the way it was. And now it's going to be all over h. So in the numerator, I'm going to expand my binomial. I'm going to distribute this minus sign to that second function. So let's go through and clean this up. X squared plus 2xh plus h squared. So I expanded the binomial, plus x plus h minus x squared minus x all over h. Remember from first quarter, we know that everything over in this f of x part should zero out. So I have an x squared minus an x squared. I have an x minus an x, so that looks good. So we have limit as h goes to 0 of 2xh plus h squared plus h all over h. So I noticed that I could factor in h out of the numerator. So I'm going to go ahead and do that. So h times 2x plus h plus 1 all over h. And now if I have an h and the top and bottom, I can cross those out. It would just be a 1. And so I have limit as h goes to 0 of 2x plus h plus 1. So as h goes to 0, this h right here gets smaller and smaller and smaller and smaller and smaller. As that goes to 0, basically what I have here is just 2x plus 1. So that's my first part of this. Now I have an equation for the slope. So this is an equation for slope of tangent line on anywhere on that function. But I want it to be at 2, 6. Let me scroll back up and make sure that's the right ordered pair. Yes, so now I want it to be at 2, 6. So 2, 6 is an x and a y. To find a number for my slope, I just really need an x. So my slope will be 2 times, my x value is 2 plus 1. So 4 plus 1. So my slope here is 5. We're going to do one last step for this problem, even though the directions don't say. Let's write an equation for the tangent line at 2, 6. And it's a tangent line to that function. And so now we have a slope of 5, and we have an x1 and a y1. I'm going to use point slope. Some of the problems on the homework will have you do this, so even though the directions don't say it here, it's worth doing. So y minus 6, 5, and then x minus 2. And then we'd add 6, and then y equals 5x minus 4. So here is problem 2. And I really think this is kind of a cool math problem. So I have a function, f of x equals x cubed. And first I want to find my average rate of change. So average rate of change is just slope when x changes from 5 to 5.1. So if I have x equals 5, then I am finding f of 5. And I'm just going to use that function. The function is f of x equals x cubed. So we'll find 5 cubed, which is 125. So that means my ordered pair is 5, 125. I also want to let x equal 5.1. So f of 5.1 is 5.1 cubed, which is 132.651. So now to find my average rate of change, I'm going to find my slope between those two ordered pairs. So y minus y, so 132.651 minus the 125. Because remember, this one right here is that ordered pair. I probably should have written them both as ordered pairs. And then my x minus x is 5.1 minus 5. So let's see, when we subtract in the numerator, we have 7.651. My denominator is 0.1, and so my slope is 76.51. So now I want to find my average rate of change when we go from 5 to 5.01. So 5 and 5.1 are awfully close together. 5 and 5.01 are even closer together. So it's still not making, this would be like an h value of 0.01, right? We're still not making that h going to 0 yet. but it's closer. So we're looking at 2 points even closer together. So let's look at, we already know what happens at 5. We already have that ordered pair 5, 125. So let's look at 5.01. So f of 5.01 is going to equal the 5.01 cubed, which is going to equal, we need a little more space on this one, 125.751,501. So now I need to go ahead and figure out my slope. I'm not going to write this one as an ordered pair because I don't have much space. So 125.751,501 minus 125 over 5.01 minus 5. Let's see. So my slope for this one is 75.1501. So my first slope was a 76.51. And the 2 points, 5 and 5.1, those two x values were awfully close. Now my two x values are even closer. So let's see what happens now when we do instantaneous rate of change. So this would be just at x equals 5. I don't have to have those two ordered pairs anymore. I'm doing that limit. So I want to do my limit as h goes to 0 of f of x plus h minus f of x all over h. So first I'm going to take that function. Remember, my function is f of x equals x cubed. And the first thing I'm going to do is I'm going to use x plus h instead of the x. So that would be x plus h cubed. So this whole thing is that f of x plus h part. Then I have a minus, and now I do f of x. Well, f of x is just the function itself, x cubed, and then this whole thing is over h. So when I cube, I need to remember Pascal's triangle. My coefficients would be 1, 3, 3, 1. So I'll have 1x cubed plus 3x squared h plus 3xh squared plus h cubed. And then remember, we have to distribute the minus here, so just really minus x cubed. So I am finding the limit as this goes to 0. Limit as h goes to 0. So let's pop this screen back up. So my x cubes are gone. I'm left with 3x squared h. Everything should have an h in it, plus 3xh squared plus h cubed all over h. And then I can factor an h out. If you cannot, you've done something wrong. So 3x squared plus 3xh plus h squared all over h. So limit as h goes to 0 of 3x squared plus 3xh plus h squared. So as this h goes to 0, this h squared becomes smaller and smaller until it's 0. 3x times the number that gets smaller and smaller is going to go to 0. So when we look at finding the limit, when we take the limit, we're just going to get m equals 3x squared. So that is the limit, which gives us that slope. So this is the slope of a tangent line. I could put it anywhere on that function, but I want to know specifically when x equals 5. So now I'm going to plug 5 in. So 3 times 5 squared. So 3 times 25. So my instantaneous rate of change is 75. So if we think about that in the context of this problem, I think once you get the answer, you're like, oh my gosh, it totally makes sense. So I took 2 points that were pretty close and I got 76.51. I made the points get even closer and I had 75.1501. If we think about what that's going to, right, we would say, well, it kind of seems like it's getting close to 75. And when we do our instantaneous rate of change, that's exactly what we have. And that's really what that means, right? We're taking 2 points that are so close together that they're like right on top of each other. That's why we're doing that limit as h goes to 0. So for our last problem, we're going to attempt a physics problem. I feel like I know just enough physics to be dangerous. So it says a ball is thrown straight up from a rooftop. So here's my rooftop, and here's my ground. Here's my windows in that apartment building. It's a really ugly apartment building. And I'm throwing a ball straight up. It has an initial velocity of 48, and it goes down and it hits the ground. So we know it's going to be something that looks parabolic. So you can see that the 48 is here in the formula. The 160 is over here. Negative 16, that would be your acceleration due to gravity. So all of those numbers have a place in that formula. We want to describe, okay, the function describes the ball's height above the ground, t seconds after it was thrown. The ball misses the rooftop on its way down, good, because that's how I drew it, and eventually strikes the ground. What is the instantaneous velocity of the ball at 2 seconds and when it hits the ground? So we'll have to find t for that second part of it. So at 2 seconds means that we're going to let t equal 2, but we first have to find that equation for our slope. So that means we're going to do that same thing. Limit as h goes to 0 of f of x plus h minus f of x all over h. And this one's going to be a little more complicated this time. So negative 16 instead of t, I guess we should probably use t plus h here. We will have a t plus h squared plus 48 times t plus h plus 160. So this is all that f of t plus h part, and then we have a minus. For the part that's just plain old f of x, we would have negative 16 t squared plus 48t plus 160. You could really use x's here if you wanted. I just started with t and I thought I should stick with it, but it's actually really hard to read with t's and plus signs. This is all over h. I'm going to pop the screen up so we can see a little bit better, put it at the top. So now I need to do a bunch of expanding this binomial and simplifying. So t squared, this will be a negative 16t squared and a minus 32th and a minus 16h squared. So I expanded and distributed all at once, which was maybe a bad idea. We'll see if we screw it up. Plus 48t plus 48h plus 160. I'm kind of running out of room. And then I'd have a plus 16t squared and a minus 48t and a minus 160. So this is my whole numerator all over h. I'm really running out of space here. So I know that this part, f of x or f of t, that thing should all cancel out, and it does. Those make a 0. Negative 48t plus 48t makes a 0. 160 minus 160 makes a 0. So we're left with only stuff that has h's in it. So negative 32th. And next year in calculus, you will learn like a really super fast way to find this expression. It's kind of painful to do this when I know that there's a much faster way. And I can factor an h out of everything again. And h over h is 1. So that takes care of our denominator. So now we just have a limit as h goes to 0 of negative 32t minus 16h plus 48. And then remember, anytime h goes to 0, Well, 16 times a number closer and closer to 0 is just going to end up zeroing out. So our slope, our instantaneous rate of change, our instantaneous velocity will be a negative 32t plus 48. So now I want to know at 2 seconds. So at 2 seconds means that t equals 2. So now all I have to do is plug that in. So m is going to equal negative 32 times 2 plus 48. And I went ahead and did some reading because I was worried. I didn't know if we're going to get a negative answer here. And I was not quite clear on that. And it occurred to me that I should probably do a little bit of reading and think about it a little bit more. And m equals a negative number. It's a negative 16. And that is apparently directional. So that means it's going down at 16 feet per second. And that's why we get something that's negative. So it is apparently a directional. And again, because we are looking at feet, and then our time is seconds, this is going to be feet per second for our slope. And the negative means it's going down. So I did do some checking around on that today before I made this video. So part B, they want when it hits the ground. When it hits the ground. The problem is I have this great expression, negative 32 t plus 48, but I don't know the time when it hits the ground. So I'm going to have to solve for that. So when I hit the ground, I know that my height is going to equal 0. So if my height equals 0, that means I can take that entire expression that I started out with, negative 16t squared plus 48t plus 60, or plus 160, and I'm going to set that equal to 0. And this is going to allow me to find the time when it hits the ground. So I can go ahead and factor a negative 16 out of all of these, which is good because I don't really want to factor with it there. And then I can divide that out because it's just a constant. So I end up with t squared minus 3t minus 10. And remember, we're finding the time when it hits 0. And then I want to factor that. So it's okay to have a negative instantaneous velocity, a negative speed, because we're looking at directionality. So my understanding is velocity takes that into account. So I don't think we can really use the word speed there. I think we need to be really specific and say velocity. But again, that's going to be more of a physics question. But it does not make sense to have a negative time. So I'm going to throw that one out. I'm only going to use t equals 5. And if I go back up to my drawing, if I think about how parabolas are, let's see if I can get it to stay up here. If I think about how parabolas are symmetrical, the negative 2 would be over here. But I didn't start throwing from that bottom, right? I threw from the rooftop, and that's why that part doesn't exist. And then 5 would be over here. So I could even find my peak, right? I could even find in the middle. So that would be halfway between the 5 and the negative 2. I think that's like 1.5 or something. And we could get that also by completing the square. So there's a lot of really cool stuff going on here that maybe builds off the stuff that you've done with parabolas the last couple of years in math, but I know last year was a little bit weird. So once we have our time, and now we're going to go back and use that expression for instantaneous velocity, negative 32t plus 48. I think I'm going to go look up some stuff today again about velocity and speed and share that tomorrow in class. I want to be careful that we're not passing on misinformation, but I also don't want to give you so much information that I confuse you, but I do want to be really precise in my language. So when I put 5 in, let's see, I got to do a calculator. I did the other one in my head, but this one I cannot do in my head. So 32 times 5, this will be a negative 160 plus 48. So m is going to be a negative 112. And again, that'll be in feet per second because my function is for feet. And then my t was seconds, so I've got feet per second. And the negative is a directional thing again, that I'm going down. So this would be like right when that ball finally smashes into the ground. This is how fast it's going. And this is the end of our 11 for notes.